So this is lesson 7B for unit 7 on chemical quantities. For this lesson you need to have a calculator and a periodic table handy. So what we're going to be doing today is a couple of things. We want to be able to take problems and solve for moles and take problems and solve for mass. And we're also going to work on a problem solving strategy to help you tackle these problems when you encounter them in chemistry. So remember, we learned the other day that a mole is equal to 6.02 times 10 to the 23rd things. These things can be atoms, molecules, formula units, ions, puppy dogs, doesn't matter what we're talking about. Okay? It's that many things. So we also learned molar mass, and that's the mass of 1 mole of something. And this is where we add the numbers up off the periodic table. So since I have 2 hydrogens, okay, I can say that each hydrogen is 1.01 gram, multiply it by the 2 for the 2 hydrogens, there's 1 oxygen, and I add them up and I get my 18.02 grams per mole. Now, this is the same thing as saying 1 mole of water equals 18.02 grams of water, and that's going to be very important for today's lesson. So let's start with a practice problem. How many moles is 5.69 grams of sodium hydroxide? So we want to circle what we're looking for and put a box around what we're given to start. Okay, so this is part of our problem solving strategy. Circle what you're looking for, put a box around what you're given to start. And I'm going to start with that information. So the 5.69 grams, I'm going to start with what I'm given. And I'll write that down. So 5.69 grams of sodium hydroxide. And then I'm going to draw a line underneath it and a line across like that. Sometimes in math or science this is called a picket fence or T-bars, something along those lines. Okay? Now, it's really important in chemistry to make the units cancel out. If you can cancel units, you can do anything in chemistry. So in order for units to cancel out, whatever these units are right here, this grams of sodium hydroxide, I need the same exact units diagonal down in order to cancel out. And I know a relationship between grams and moles, so I can change it to 1 mole there. Now, one of the things I want you guys to do is to get in the habit of putting in the units first and then the numbers last. So I need to ask myself, do I know a relationship between grams and moles? Well, yes, I do. I can take a look at the periodic table and get the mass of that. So I add up my sodium hydroxide off the periodic table. Sodium is 22.99 grams per mole, oxygen 16.00 grams per mole, and then finally the hydrogen 1.01 grams per mole. I add all this up and that equals 40.00 grams per mole. Remember, this is the same as saying 1 mole is equal to 40 grams. So I can take this information and fill it into my chart. This 1 mole, well, that's this 1 mole right there. And the 40 grams is going to go there, right next to the grams. Okay? So now I've got a very simple math problem to solve. I multiply the numbers across the top. I hit divide for every number across the bottom. So, and again, in your calculators, you can just skip the ones. You don't have to multiply and divide by the ones. So in your calculator, 5.69 divided by 40. And this is what your calculator is going to spit out. But we want to pay attention to significant figures, okay? And to do that, we need to look at our original problem. This right here is 3 sig figs. This 40.00 is 4 sig figs. These zeros count because of the decimal. This right here is considered infinite sig figs because it's like a conversion factor. I have exactly 1 mole. So my fewest number of sig figs is 3 sig figs. So that's what I'm going to round this down to. I get to take the first 3 significant digits, which is those, look to the next number to round, and it becomes 0.142 moles of sodium hydroxide. So let's do another one. Determine the number of moles and 128.14 grams of sulfur dioxide. All right? So first thing you want to do, you want to find what you're looking for and what you're given to solve the problem. I'm looking for the number of moles. I'm given 128.14 grams to start. All right? So I'm always going to start with what I'm given, and then I can draw my picket fence here. Okay? Now, I really do want you to write the units, because what happens is when students skip the units, they get lost. And I want you to write the chemical. I want you to write this SO2, because next week it's not going to be the same chemical in the entire problem. We're going to switch chemicals. Now, in order to make these units cancel out, I want the same units diagonal down, so grams of SO2. And I can change grams into moles. I look for my relationship between moles and grams. By doing this, grams comes off the periodic table. I add up 1 sulfur and 2 oxygen, and I get 64.07. That's the same as saying 1 mole. So 1 mole goes up here, equals 64.07. That's the number that's going to fill in there. Okay. So at this point, I can multiply the numbers across the top, divide by the numbers across the bottom, and this is what I get. And one thing I forgot to point out on the last problem is these units cancel. That's what we're looking for. We want to be left with whatever the problem was looking for. I have moles left over. They don't cancel out. That should be what the problem was asking for. That's how I know I've set my problem up right. So you go ahead and do the math. The calculator spits out 2. But remember, we want to look at our sig figs. So this right here, this is 5 significant figures. This one here is 4. Remember, this 1 is always going to be infinite, so I'm not going to have to worry about that one. So I want to round this to 4 significant figures, which means I've got to put some zeros on the end to make that 4 sig figs. Okay, so what would 2.34 moles of carbon weigh? Okay, weighing is another way of saying getting the mass, finding the grams. Okay, so that's going to mean I'm looking for grams in this one. And I'm given that 2.34 moles of carbon to start. Now, ideally what I would like you to do is I'd like you to pause this if you're watching it and try it out on your own, and then hit unpause and see how you did, because that's really what happened in class. So we start with our 2.34 moles. Diagonal down need to be the same units so that they cancel out. The units I'm looking for go right there on top. I have my relationship between grams and moles. Moles is always going to be a 1. Okay, so 1 mole is equal to 12.01 grams of carbon. And I get this 12.01. This comes off the periodic table. Remember, grams is always going to come off the periodic table. I multiply across the top, I divide across the bottom. I get, of course, moles cancels out, and this is what I get. I take a look at my sig figs. Here there's 3 sig figs, and here there's 4 sig figs. And again, the 1 is infinite, so I'm going to round this down to 3 significant figures because I always go with the least. And I get 28.1 grams of carbon. Okay, one more. How many grams are in 111.7 moles of iron 3 oxide? Okay, Fe2O3. And again, I really would like you to pause and try and solve this problem on your own, and then check your answer. So in this problem, we're looking for grams. We're given an 111.7 moles. Set up what I'm given first. That's always going to go there. Diagonal across the bottom so the units cancel out. We would see these cancel, moles and moles. The units that I'm looking for always go right here. They want to go at the very end. I need a relationship between moles and grams. 1 mole equals the number of grams off the periodic table. So 1 mole of iron 3 oxide is going to equal 159.70 grams per mole. Okay? Do the math, multiply the numbers across the top, divide by the numbers across the bottom. I get my moles canceling. I'm left with my proper units of grams. So I set up the problem correctly. This is what the calculator spits out. I want to check my sig figs. This is 4 sig figs right here. This one is 5 sig figs, and of course infinite. So I want to round this down to 4 sig figs, which is my least. And that's what we get, 17,840 grams of iron 3 oxide for the answer. Now, on this day I did have an exit slip, so it's really important if you were absent to talk to me about questions you might have had. This goes pretty quickly if we weren't doing it together in class.